concrete. When I saw something recently about concrete, I guess let's watch this one first. Why not? I was seeing something, I think it was on Reddit, about how, 1,000 years ago or something, the Roman concrete was so much better than the one we have today. And in proof is that there's a lot of place in Europe where there's still like piers and ports and stuff like that, where most of the foundation is from like Roman concrete. But I didn't really read why it was so much better, just that it was so much better. And as always, what I thought is, damn, I can't stop thinking about the Roman Empire. So by practical engineering, concrete greatest weakness is time.
On March 2nd, 1973, the Skyline Plaza Tower was under construction in a suburb of Washington, D.C. Crews had just placed a portion of the floor slab for the 24th story, just 2 floors short of the project's final height. Shortly after lunch, workers noticed that the new slab was deflecting. Suddenly, a portion of the building collapsed, killing 14 and injuring many more. The collapse left a gap in the building 18 meters or 60 feet wide, essentially slicing it in two. Investigators later found that workers had removed the formwork and the shoring for the lower floors too early. Because of cold weather, the already placed concrete in those lower floors hadn't gained strength as quickly as they expected. Without the shoring transferring loads into the structure below, the undercured concrete was forced to bear the weight. And it just wasn't strong enough. Concrete is an incredible material. I've covered a lot of concrete topics in previous videos. There are good reasons why we use so much of it in the built environment. But, and this is hard for me to say, it's not without its flaws.
Everything has
Putting
flaws.
aside the environmental issues, as a building material, concrete creates challenges that are unique and
Oh, it's
in
a
many
miss.
cases
Oh, I see.
not that well understood.
I got tricked by
Those
Reddit.
building materials,
You could
after
have
they're
thought.
fastened or put in place, are immediately ready to use. That's not true for concrete, and even if it seems kind of obvious, it creates some really interesting challenges for engineers, architects, and contractors. So I've cast some concrete cylinders in the garage, and we're going to break them to understand this weird property of concrete and some of the ways we work around it. I'm Grady, and this is Practical Engineering.
Interesting.
As soon as water meets the cement in concrete mix, the clock starts ticking and there's basically no stopping it. The working life of concrete consists of 2 key phases, and they demand almost opposite properties. Phase 1 has to be workable and easy to shape. Concrete placement and finishing is a ton of work with a lot of steps that each have to happen at the right time. Of course, the second phase is strength. No matter how beautifully formed concrete is, it's useless unless it can handle its design load. The process begins even before the concrete arrives on site. Most large jobs rely on ready-mix batch plants where ingredients are measured and blended according to project specifications, then loaded into rotating drum trucks for delivery. Concrete is relatively cheap by weight compared to other building materials. At its most basic, it's just sand, gravel, cement, and water. But placing it is labor-intensive, time-sensitive, and expensive. Plus, many projects use a lot of it. So it's important that the right stuff makes it to the job. Engineers often put strict specifications not only on the ingredients themselves, but how the concrete is handled on the way to the job site. Some even put limits on the number of drum revolutions allowed before the concrete's dispensed, helping to prevent ingredient breakdown and loss of entrained air. Once on site, the first task is getting the concrete into the forms. At this stage, workability is everything. It doesn't need to flow like water, but it should move easily enough to be placed quickly and completely. You want some flow, especially for complex shapes or
I was thinking I have actually no idea how long it takes to harden once you've put water in. And that's stupid because I've been on like house construction site before. My dad used to work for like a wooden wooden house construction company, but they would still use concrete for a bunch of stuff. And so, I was around the round thing, the round cylinder thing that turns around. I don't even know what it's called in French, so I can't tell you in English. Like the mixer thing. And I remember a few times, like, I was there because I wasn't allowed to stay home alone for some reason. And I was told to like just keep pouring water in it or something. Uh, but yeah, I don't even remember like how long it takes to harden or like to be ready. Even not being an engineer myself, it's still an important thing to know as a concrete form worker. Fair enough.
Or when you have a lot of reinforcement. Next is consolidation, usually with vibration or agitation to get rid of excess trapped air. For slabs, workers screed the surface to level it, then use floats to push down coarse aggregates and prepare for the final finish. This is physically demanding work, and every step has to be done before the mix becomes too stiff to work with.
Yeah.
You do have some tools to manage this process. Admixtures can adjust the set time and improve workability without adding extra water, which would otherwise weaken the final product. But the water in concrete isn't a solvent that dries out. Concrete cures through a chemical reaction called hydration. The water becomes a part of the concrete. And that hydration process can be affected by job site conditions like temperature, wind, or delays at the batch plant.
I guess it's bad
which
if it's
are
raining
out of
then,
your
yeah.
control. That
It's really bad, huh?
unpredictability can make a big concrete pour extremely stressful. You don't get do-overs. Depending on conditions, concrete typically reaches its initial set in about 2 to 4 hours.
Know what we're working
That's
with.
when the mix is firm
That's fair.
enough
That's
that
fair.
you can't easily press a finger into it. At this point, it's ready for finishing, whether that's troweling for a smooth floor, grooming for a textured sidewalk, or stamping for decorative work. Each technique has to happen during a short window between the initial and final set, when the concrete is firm enough to support workers but still soft enough to shape. On big projects, timing is critical. Standardized tests are often used to measure
That sounds very
set times
stressful.
and guide trial batches so that each task can be scheduled precisely. After final set, the next phase begins waiting. I cast a bunch of concrete cylinders to show you exactly what I mean. It's 24 hours later, so let's get these on the hydraulic press. I've got Brady in the shop supervising the process, and my scale isn't calibrated, so we'll do all the comparisons in arbitrary units of force. Some people suggested kilogradies last time I used this, so let's go with that. Even without looking at the scale, you can tell these samples aren't very strong. Under the press, they kind of crumble more than break apart, and this is pretty typical. After a day, concrete's strong enough to walk on, and depending on the structure, this could be a good time to strip off formwork, but you're not going to get away with much more than that. I broke 3 cylinders and we'll plot them on the graph like this. Let's fast forward to 7 days. For large projects, the concrete specifications often require a test.
Well, see, it really shows how much I didn't know, right? In my head, it's like, I thought it's probably like just a day or two for it to be fully ready. So no, I guess there's still like quite a bit of time once you've put the water to like lay it out and shape it. It's still like low, but it's not as low as I thought,
At this point. It's the same idea as what I'm doing here, just with more sophisticated equipment. Samples collected on site are put in cylindrical or cubic molds, taken to a lab, and cured in controlled conditions. Then they're put into a press, much more complicated than this, and the force required to break them is measured. The idea behind a 7-day test is that if the concrete isn't going to reach its required strength, you want to know as early as possible. Let's put these test results in our graph. The average was 9,300 kilogradies, so a 3 times increase from the 1-day breaks. Strength gain usually follows a fairly predictable curve, so early results can be extrapolated with reasonable confidence. If something's wrong, you can often tell early and start planning accordingly, even if that means tearing out a pour and resetting the schedule. As costly as it sounds, it's nothing compared to the consequences of trusting concrete that isn't as strong as the engineer assumed in design. This highlights one of the biggest challenges with concrete. You can't fully test quality until after installation. Most building materials go through inspection before arriving on site. With concrete, You could test the raw ingredients and even make trial batches, but the real test is whether the mix you placed in the formwork meets strength requirements after it cures. That uncertainty adds risk. To hedge against it, suppliers often design mixes with extra strength margin to make sure that even with some
Makes
random
sense, yeah.
variation, strength will never come in too low. Sometimes waiting longer can help a borderline mix catch up, but in some cases, a failed strength test really does mean tearing everything out and starting over. Another complication is where samples are cured. Standard lab specimens are kept in tightly controlled environments. That helps verify that the supplier met the required mix specifications, but it doesn't always reflect conditions in the actual structure, where temperature, humidity, and weather can vary wildly. That's why many projects also include testing of field-cured samples, which gives a more realistic picture of the in-place strength. If this had been done at the Skyline Plaza, the cold weather delays in curing might have been caught, preventing a
Hmm.
costly and deadly failure when shoring was removed too early. On a well-run job, a good 7-day result gives confidence that everything is on track. Even though the
All
concrete
right.
hasn't reached its target strength yet, you have a solid indication that it will. I also broke some 14-day samples, not typically required on jobs, but useful for seeing the big picture.
Right in the arm.
The graph shows that strength continues to rise, though the rate is already slowing. Let's jump ahead 2 more weeks. 28 days is a fairly arbitrary but widely used benchmark for when the rate of hydration flattens out. Usually, when we talk about the compressive strength of concrete, 4,000 psi or 28 megapascals or 10,000 kilogrades per square smoot or whatever it might be, we're talking about the
I'm lost.
minimum 28-day strength. A significant amount of concrete engineering is based on this strength. The goal is that 28 days after placement, you can feel confident that the structure will perform up to the maximum loads as it was designed. My 28-day samples broke at an average force of about 11,000 kilogrades, about 20% stronger than the 7-day ones. Pretty close to the rule of thumb that concrete reaches about 75% of its final strength after 1 week. But you see the problem here. A month is a long time, and time.
Yeah, so I was gonna say, like, do you actually wait a month, or do you start building whatever you need on top of it after like a week when it's like, almost there? And I guess you start by doing like the lesser load on top of it while it's still like hardening.
Is money in the world of construction. There are some things you can do in the interim, maybe install anchors or apply light loads. For a sidewalk or a driveway that rarely sees heavy vehicles, concrete might be strong enough at 7 days, but for applications where the margin between expected loads and material strength are tighter, you just have to wait, and this can be a real problem in some cases. Think about concrete roadways. How long are you willing to wait to keep a lane closed after a repair? Tall buildings have a similar problem. If you wait 28 days for every floor to cure, it's going to be a long and slow project. You can see how concrete cure time turns into a serious bottleneck and can often become the critical path on a construction schedule. Luckily, there are a few ways to speed things up. One is just use a stronger mix. The logic here is simple. Say you need a 4,000 psi concrete, but you don't want to wait 28 days. If you use a 5,000 psi mix design, theoretically you'll hit 4,000 psi after just over a week. This adds material cost, but the time savings can make it worthwhile. Other strategies include using high early strength cement that's ground more finely to speed up hydration, or altering the mix ratio by adding more cement or reducing water. Heating the mix water or curing under blankets can also help. Chemical accelerators are another tool. Calcium chloride is a popular choice because it's cheap, but it has drawbacks. Chloride ions can speed up corrosion of steel reinforcement, so a lot of engineers won't allow calcium chloride in concrete in their projects. Non-chloride accelerators, or NCAs, have gotten better over the years and may be a safer alternative, but they still pose challenges. The curing of concrete is an exothermic reaction, so faster hydration generates more heat, which can lead to cracking as the concrete cools. And of course, it shortens the working time for placing and finishing. I hope you can see all the complexity in this.
There's more than I knew, that's for sure.
Concrete to do, and
Lighter
because it
stuff, keep the
hardens
temporary support while
relatively
working on the
slowly,
next elements.
there's a lot riding on how and when concrete gains strength. It's not.
I mean, you know, as I always say, you know, my knowledge is so lacking in some basic things, you know, and I had no idea. Like, if you asked me before this video, for me, concrete is like, you know, as I said, the few elements plus water, and there isn't more to it. I never really thought about it, like, there's much more to it, you know? And I guess I didn't even know how long it takes to really harden properly. Like, I would have said, like, 2 days or something before. It's pretty interesting, though. Yeah, definitely makes me look differently at a lot of things, you know, like building houses and buildings and roads and all that, and the system of it.
Not just about stripping forms or removing shoring. In many construction projects, the strength gain of the concrete governs every downstream operation. It determines when floors can support framing, when roads can open, and when a project can move forward. And there's nothing magical about 28 days, it's just 4 weeks. It's a number of convenience that makes it easy to talk about concrete strength and compare properties. In fact, most concrete will continue to gain strength for months or even years after that first 4 weeks, depending on the mix design and steps taken during curing. And many projects require that it does. Compressive strength isn't everything when it comes to concrete. There are time or exposure dependent failure modes like shrinkage, creep, and long-term degradation from freeze-thaw that play an important role in design. So some projects, like dams and bridges, often have 90-day requirements to ensure that the concrete eventually reaches a strength to resist them, even if it doesn't need to happen right away. But that 28-day convention gives a hint about concrete's greatest weakness: time. Really, no other structural material requires you to wait weeks before knowing whether it will actually perform as expected. While most materials arrive on site ready to use, concrete requires a leap of faith, and then a long pause. Concrete is strong, durable, and incredibly versatile. There's nothing like it. It's a building material worth celebrating in many ways, but only on its own terms. You can place it quickly, you can shape it into nearly anything, but you can't rush what happens next. That's the challenge and the art of concrete construction. It's a balancing act between
much more complicated than it
and waiting long enough. It's a material that embodies both a sprint and a marathon. A lot of people don't think about concrete as an academic topic, but because of its importance across the globe, there are a lot of researchers who spend their entire career studying it. I read a lot of journal articles about concrete as research for this video, most of them helpful if not particularly groundbreaking, but every once in a while an academic paper takes on a life of its own. That's the story told by my friend Kevin of the Bobby Broccoli channel in the new documentary 17 Pages. A single paper sparked a scandal so big it was called the Scientific Watergate. 17 Pages dives deep into one of the most controversial science ethics cases of the 20th century, and if you want to check it out, it's only available on Nebula.
I should have known a video like this would be sponsored by Nebula, yeah. I'll plaisir, but yeah, thanks for the sponsor, Nebula, with funding those great history or science videos. Really good stuff. I didn't really have much to comment because, you know, I'm kind of blind on a lot of this, so I was just learning, basically. Yeah, I mean, now I know concrete is a much more complicated thing than I ever thought, you know. Really didn't know it was this deep, I guess, is all I can say. And it's funny because, yeah, it made me remember that when I was young, a few times on like work sites, I was like adding the, you know, the bag of stuff and the water to the spinning thing, and I just remembered this. Yeah, really interesting. I learned quite a bit. So good video from the Practical Engineering channel. Here's the link. Very interesting. I learned quite a bit. There's a kind of saying, like often people will say, like this is something you use every day. I do not understand it. People will say that about a car, for example. Like I understand how a car works, but not to like a very detailed level. And I guess it's the same thing with concrete. I mean, it's one of the things that's like so common. I don't even think about how it works. I'm happy that it exists and it works, but I don't even think about it, I don't even think of learning how it works or anything. There's a lot of things like that. I guess there's too much to learn in life. That's one of the things.